Hi, today we're going to look at rational functions, and we're just going to look at the first part of rational functions, which is one-sided limits and behavior. But before we start with that, let's just make sure to review what a rational function is. It is a function where you have a polynomial as a numerator and a polynomial function at the denominator. So there does have to be a variable at the denominator as well. Remember that there will be restrictions since the denominator cannot equal to 0, and that's where you're going to come up with these asymptotes that we're going to look at. So the first thing we're going to look at are the asymptotes. The asymptotes you're going to have are going to be horizontal asymptotes or vertical asymptotes or oblique asymptotes, and we're going to look specifically at slant asymptotes, where the equation of this asymptote would be y is equal to mx plus b, or if it's a vertical line when x is equal to a specific x value, or horizontal asymptote when y is equal to a specific y value. So those are going to be the equations of our asymptotes. But before we start with the equations, we're going to look at end behavior and one-sided limit. Now, we've talked about this before, so this part is going to be called your one-sided limits because we will be approaching the vertical asymptote. So this is going to be the vertical asymptote. Now, the vertical asymptote, there's going to be two sides to it. You're going to look at the right side of that vertical asymptote. That's what that plus means up here. So this is saying as x approaches that x value from the right. And then this one here, it says x approaches that x value from the left. Now that's going to be your one-sided limit. Sometimes you're going to have two because they are going to come in pairs because you're going to look at the right and the left side. And then the other one here is your end behavior as it approaches infinity or negative infinity. And we've talked about this one before as well as this one when we looked at other functions. So let's look at the graphs of these rational functions. So you are going to have either a vertical or a horizontal or both, or you can even have a slant asymptote. So notice here it's going to have a horizontal asymptote at 0 and a vertical asymptote at -2. So when we are talking about end behavior, we're looking at the end of the graph. So towards the end of it. We don't care what's happening in the middle. So we're looking at it as x approaches infinity and as x approaches negative infinity. What is this graph going towards? So notice here is the limit as x approaches infinity of the function. So here's the function, and I'm approaching when x gets very, very large. This function gets very, very close to 0. If we do it the other way, the limit as x approaches negative infinity of f of x, so notice this is the function, and I'm getting to the x values that are very, very, very small, it's getting closer and closer to 0. So that's the end behavior, which we've done before. Now let's look at one-sided limits, and that's the one we're going to be looking at now. The one-sided limits are looking at the vertical asymptote. So whenever there's a vertical asymptote, there's going to be two parts to it, the right side and the left side. So what you're going to write is the limit as x approaches that vertical asymptote, which here it's -2, from the left of that function, and the limit as x approaches -2 from the right of that function. So here's -2, and I want to approach it from the left. So I'm getting the function, and I'm getting closer and closer to that -2. As I'm getting closer to that -2, the function goes to infinity. Here, as the function gets closer and closer to -2, but from the right side, because that's what that plus means, it's getting closer and closer to negative infinity, because notice it's going down. So let's try some here. So this is a rational function, and notice I'm going to ask for the end behavior. And then I'm going to ask for the one-sided limits. Now notice that because I have two vertical asymptotes, I'm going to have four limits, one-sided limits, because I have to look at the right and the left of each vertical asymptote. So let's do the end behavior. So remember, end behavior goes as x goes to infinity and negative infinity. So notice here, as the limit as x approaches negative infinity of f of x, so I'm going to get the function, and I'm getting closer and closer to that horizontal asymptote, which is 2 here. Notice on the limit as x approaches infinity of f of x, this one gets closer and closer as well to that horizontal asymptote, which is 2. So if you notice, even from the previous one, the end behaviors will always go towards that horizontal asymptote here. Now let's try the one-sided limit. Let's do the vertical asymptote to be negative 5. So notice how we write it. The limit as x goes to negative 5 from the left of that function, and the limit as x approaches negative 5 from the right of that function. So we got to look at negative 5 here. This is negative 5, and we're going to look at the right side and the left side of it. We don't care about anything else. So as x approaches negative 5, notice that the function is increasing. So that means that it's going to infinity. As x approaches negative 5 from the left, notice that the function is decreasing. So it's going to negative infinity. Let's try the other vertical asymptote, which notice here, it is at positive 5. So we write it the limit as x approaches 5 from the left of that function, and the limit as x approaches 5 from the right of that function. So here we go. We're going to start from the left. So as x approaches 5 from the left, notice that it is decreasing. So that one's going to negative infinity. And then the limit as x approaches 5 from the right, so I got to come from the right now, and I'm approaching 5 from the right side, it is increasing, so it's going to infinity. Now let's try it with where I don't give you the information, where x approaches something, where you have to actually write it, because that's how you will see it. So this is the graph, the rational function graph that they're giving me. So we're going to try it. So the first thing we're going to do is the end behaviors. So the end behavior is when x approaches infinity and when x approaches negative infinity. So we're going to find the limits as x approaches infinity, which is this way, and as x approaches negative infinity, which is on this side here. So as the limit as x approaches infinity, so we're getting on the x values, we're getting very, very large. Notice that it's getting closer and closer to that horizontal asymptote here, which is 0. The limit as x approaches negative infinity of that function, so I'm getting the x values to be very, very small. Notice that function is getting closer and closer to 0. Now we're going to do the one-sided limit. Now, if you notice with the one-sided limit, we have two vertical asymptotes. We have one at negative 4, and we have one at 2. So we have to do negative 4 from the left, negative 4 from the right. We also have to do the other vertical asymptote. So 2 from the left, 2 from the right. So the limit as x approaches negative 4, so here's negative 4, from the left, notice that it is decreasing, so it's going to negative infinity. And the limit as x approaches negative 4, but from the right, so I'm approaching negative 4 from the right, it's increasing, so it's going to infinity. Now let's try the 2. As x approaches 2 from the left side, it's going to negative infinity because it's decreasing. And the limit as x approaches 2 from the right side of that function, notice that the function is increasing. So it's going to infinity. Okay, that is all we're doing today, which is the end behavior and the one-sided limit.